In this video, we're going to talk about monorepos. We're going to talk about why they exist, what they are, when and why you might use them, and then I'm going to take you through some tips and tricks for working inside of monorepos by showing you a real-world full-stack React application that I put together that has a Vite and React frontend and a Hono API backend that all live inside of the same monorepo. If that sounds good to you, let's dive in. My name is CJ. Welcome to Syntax. So let's break it down. Mono means one, and repo is short for repository. So it is one repository. Essentially, you have one repo where all of your apps, all of your packages, all of the things that potentially make up the product that you're working on. You might have an API, you might have a React front end, you might have a Next.js landing page or marketing page, you might have a package that's shareable UI components, you might have another package that's shareable types. So it's essentially a way of structuring all of your apps and codes into a single repository. Now, a lot of times when people hear monorepo, they think of a monolith, and that is not what a monorepo is. A monolithic application is one big application. Think of something built with Ruby on Rails, where it has all the front-end code, all the back-end code, all the database. Everything lives in the same app. That's a monolithic application. That's different than a monorepo, which could have multiple apps and multiple packages. Now, that's not to say that you couldn't have a monolith inside of a monorepo, but they are two distinctly different things. Now, why on earth would you want to do this? It mainly comes down to code sharing and code deduplication, right? Let's say you're working for a company that potentially has two different React apps. Maybe you have an admin dashboard, and then maybe you have like a client-facing tool. Both of those apps potentially are styled in the same way and potentially want to use the same components. So a monorepo would allow you to have both of those apps living next to each other in your apps folder, and then you can have a package called UI components that defines all of your reusable components. It could use storyboard, it could have tests, all of that could live there, but then both of your applications could easily import from it and share those reusable components. Now, another reason we might use monorepos is to share types. And so for instance, you could have your API also inside of this folder, and then you could potentially have another folder inside the packages folder called types. And then you could define all of the reusable things there, like tasks or users or all of the things that you potentially need to use in both your front end and in your back end. And with a monorepo setup, now all of that code can live in one place and then easily import it into all of the places that need it. And now you have a single source of truth instead of needing to copy paste these types or define them in multiple places. Now, another type of shared code you might have are utilities or formatters, right? So let's say the front end and the back end both need to format strings or dates in the same way. You could define that code in a package inside this monorepo and then use that package as a dependency in both your front end and your back end. You might also have utilities for like converting values or doing things that aren't specific to the front end or back end, essentially like business logic that you might need in both the front end and the back end. And you can define that inside of a shared package inside a monorepo. Now, another reason you might use a monorepo is potentially the structure of your team, right? So if you have a cross-functional team where people are sometimes working on the back end, sometimes working on the front end, a monorepo helps with that because it's all within a single code base. So it allows for more easier collaboration instead of needing to hop between various repos depending on what you're working on. Now, another reason you might use a monorepo is if you work at a company where you need to keep everything internal, because a lot of the benefits I've talked about so far are code sharing. And you might have just thought, well, can't I just publish all of my packages to npm and then add them as dependencies that way? Yes, but that's really only if your code is public. If you work at a company where you have proprietary code or things that you don't want to share with the world, a monorepo makes it much easier to share those dependencies without needing some sort of privately hosted package repository or different things like that. Now, some of the reasons you might not use a monorepo is if you potentially need to control who has access to what code, right? Because once you're working inside of a monorepo, everything that lives in there is a single repo, so you must give anyone that wants to work on it access to that whole repo. So if you work at a place that likes to keep things a bit more secure and siloed based on a person's role or where they are in the company, then a monorepo probably isn't the way to go. You probably want to have some sort of internal private package repository host so that if people need access to things as dependencies, they could be easily installed. But if they need access to the direct source code, then that can be handled via giving them direct access to a specific repo versus giving them access to an entire monorepo. And then another downside of monorepos is that it requires more storage, right? So everything lives in this exact same code base. So any developer that needs to clone it down has to clone down all those apps and all those packages. So at a certain point, this actually could get very large, especially if there's a lot of Git history. And then one last downside potentially is figuring out how to deploy a monorepo. A lot of deployment services don't play very nice if your apps don't live in the root directory. And so you're going to have to figure out some build processes to make sure that all of these apps living in this monorepo can be deployed to wherever you need to deploy them to. Now let's look at some real-world examples of monorepos. And if you haven't heard of this before, this is probably going to make things a little bit more clear when you come across various GitHub repos like this. So first, let's look at React. This is React by Facebook here on GitHub, but you will notice at the root is this folder called packages. And if we go inside of there is a folder called React, and there it is. This is the actual React core library, this folder right here. All of these other folders are sub-packages. And for instance, we also have React DOM, and we also have React Client, and we also have React Server. And it makes sense for React to be structured this way because a lot of times you may need to reach for one of these, but not the other. And so they're all defined here. And in the case of React, which is actually published publicly to npm, each one of these folders is actually published as a separate npm package. But whenever you're running this code yourself locally, like if you were to clone down the actual React repo, they have internal dependencies, right? React DOM is very likely dependent on React and has it listed as a dependency, but instead of needing to pull it from npm, it can actually reference it directly using whatever monorepo tool they use to reference these without needing to install them all the way from npm. If you take a look at Vercel's Next.js, what do you know? They have a packages directory. And if you look inside of there, there's create next app, there's next font, there's next, all of these sub-packages live here. But internally, they might need to reference each other, so they can do that within this monorepo. You can take a look at Bun. So it has this packages directory. And inside of there, you have all the various Bun sub-packages. We could take a look at TL which is an open source canvas drawing tool. And what do you know? They have a packages folder with various internal packages. They also have an apps directory that contains multiple different apps. So all of the other projects I've shown you so far are more like developer tooling or dependencies that you might install. So they don't really have applications. But in the case of TL they have applications because they're deployed to the web. So this .com folder is very likely the app that's hosted at tldraw.dev. And then docs is the app that's hosted on their docs URL, whatever that is. But inside of packages, they have all of the reusable stuff that isn't necessarily an app itself. Now, all of these examples I showed you are public open source repos, but one of the most popular examples of a company doing this internally is Google. They actually have a single monolithic repository that stores all of Google's code, everything, google.com, Gmail, everything that exists at Google, even like the Angular library, it's stored inside of their monolithic repo. And this article talks about why they do that, some of the tools they developed internally to do it. But just so you know, this is a technique that's used at a lot of places, including some of the biggest tech companies in the world. Now, there are a few different ways to go about creating monorepos. For instance, npm has a workspaces feature, and you can actually add this to your package.json, which defines where your workspaces live. And a workspace is any given package or app inside of a monorepo. So in this example, they have a package called A that lives in the packages/A directory. And so this setup would allow them to have that subpackage. Yarn also has a workspaces feature. So this also gets defined inside of your package.json. Dino has a workspaces feature, which you can put in your dino.json or your package.json. Bun also has a workspaces feature, which lives in your package.json. And pnpm also has a workspaces feature. Now, pnpm is what I'm going to be using because it's my preferred tool for working with dependencies. And they also have a lot of nice built-in things that you don't necessarily get with some of these other workspace tools. But they specifically define their workspaces inside of a workspace.yaml file. So it's not inside of your package.json. But this whole idea of packages, apps, workspaces, it's very similar regardless of what tool you decide to use. Now, for a quick demo of the app, this is just a tasks management application. So we have a React front end here where we can create some tasks that hits our Hono API, and then we receive the data back over here, and we're using tan stack router. So we do have multiple pages. We have the task view page. We also have the task edit page where you can delete tasks. And the main goal of this is to really just demonstrate having multiple client-side routes, because in a more complex application, it would be similar. You just might have more fields than just the name field for a task, but it would work in potentially a similar way. Now, first up, inside of our repo, you can see we have this pnpm-workspace.yaml file. And this is how we tell pnpm where our workspaces are. In this case, we have two different folders. We have the apps folder, and this folder contains applications. So like APIs or Vite frontends or React frontends or Svelte frontends or whatever else, all of that's going to live in the apps directory. And then we also have the packages directory, and this is going to be any reusable code that isn't itself directly in applications. So we could have reusable types, reusable utility functions, reusable components, those different types of things, and they're going to live in the packages directory. So to set this up, make sure you have a workspace file, and then from there, each of those folders can now start to have those applications. And what you'll notice is every single one of these folders within apps and within packages has its own complete setup. So each one of these has its own package.json and configuration, and each one of these apps also has its own package.json and configuration and everything else. Now, one of the aspects of working with pnpm workspaces in a monorepo is these packages and these apps can reference each other without needing to be published to npm or GitHub or anything like that. So for instance, I have this shared eslint config, which I'll dive deeper into in a second, but this package is defined here, and its name is @tasks_app/eslint config. Now, any other package or app that I have in this monorepo can reference that package via the workspace. So for instance, this API client, if we look at its package.json, it has a dependency on task app/eslint config. And then you can see the version here is specified as workspace. This lets pnpm know that whenever we're installing dependencies, this should be found in the workspace by looking at the workspace config to see what those workspaces are. And it should be installed from there. It shouldn't try to reach out to npm and install it from there. So in this case, our packages can reference each other. So in the case of this API client package, it has a dependency on the API because it needs its types to create that client. And so if we look at the API package.json, it has a dependency on task app eslint config. And you'll notice that all of my packages are namespaced as @/tasks app. And you basically want to do this so you don't run into any conflicts, right? If I just called this package API, we could run into conflicts of like real packages from npm being called that. So you want to make sure that you namespace this to whatever your application or whatever your company is. And so every single one of my apps and packages in here all uses that exact same namespace. And this is also convenient because whenever I'm looking at imports in my code, if I see that it's coming from my specific namespace, I know that this code is coming from my workspace. It's not coming from npm or anything like that. And so this is one of the major benefits of pnpm workspaces is you can have this structure where each one of these packages or apps has its own configs and own way of doing things, but they can all reference each other to like reduce duplication and also share code and configuration. Now, my first tip for working in monorepos is to share as much of the configs as possible. Now, this is very time consuming and cumbersome to set up, but it's definitely worth it. So in this app here, I have a tsconfig at the root that has all of my default settings, and then every other app or project then extends from this tsconfig. So if we look at the tsconfig in my API client package, it extends that config and then adds all of its own specific settings. If we take a look at apps and then API, it has its own tsconfig, but it extends from that same base tsconfig and then adds all of its project-specific settings. And then we have the exact same thing inside of our Vite app, which is slightly more complicated because it has a couple of tsconfigs, but both the app config extends and then adds any options that it needs to, and then also the node config extends and then adds any options. But you'll notice for all of those configs across my projects and packages, none of them have to specify these settings because they're all specified in the base configs. So this gives me a nice, consistent TypeScript experience across all of my code because they have the same base settings. Another piece of config that we're sharing is our eslint config. And for this, I've actually defined a package inside of my monorepo. So here in packages, I have eslint config, and this defines my base config. And then every other app or package I have can extend that config, but if they don't need to make any changes to the settings, they can just use this default config. Now, my base config is using Antfoo's eslint config, which is my preferred way of setting up eslint these days because it has a bunch of built-in plugins and a bunch of good default settings. But from there, I can customize it to have all of my preferred stylistic settings and add all of my preferred overrides for rules. But now these settings are the same across all of my projects. And for this package, I actually have two different exports. So if one of the packages or apps in my monorepo just needs to use the config and doesn't want to make any modifications, it can reference that config file directly. But if they do want to make customizations like enable or disable rules or add different plugins that are project specific, they can pull in this create config and then pass in their own custom settings that get overridden here. So for example, if we take a look at our API client package, it just pulls in that config directly. It doesn't make any modifications. It's using all of the defaults. If we take a look at apps and then API, this one is making a few modifications because I need to add some new ignore rules. And then also this is a backend that's using Drizzle. So I'm using the Drizzle eslint plugin. But because I'm using that create config function I made, it has all of the base settings. And then these are all of the overrides. And then same thing for our Vite React app. So it essentially needs to enable all of the React ESLint rules for accessibility and hooks and everything else. And then I can also add plugins that are React specific, and then also turn off or modify some of these other rules specifically for this React app. But now no matter where I'm working, whether it's the back end or the front end or in a package, they all have these exact same rules so I can ensure a consistent dev experience. Now, my next tip deals with setting up path aliases. Now, I have multiple apps here, and in each one, I want to be able to have some aliases. So if we look at the tsconfig in our API, it has a path alias of @/API. And this is my tip. Essentially, if you're going to set up path aliases, every single app should have some unique prefix. Because in some build scenarios where packages are dependent on each other, you potentially will need to set up these paths for the dependent packages, and it can get confusing or conflict if all of your path aliases are just @/. So for my API, its alias is @/API, and then for my React app, its alias is set up @/web. And so this way, if these packages are dependent on each other, we can actually set up path aliases that correspond to the correct package. So for instance, our API client is dependent on the API, and if we look at its tsconfig, we actually set up the paths here so that whenever it sees @/API, it knows where to find that code. And if it was just @/, this potentially could conflict if it had a dependency on web as well. So that's my tip, is set up your aliases to be specific to each project so you can differentiate them and you don't run into any conflicts. My next tip is to use the built-in task runner of pnpm. So I have two apps here. I have my Hono app and my React Vite app, and both of them have a dev script. But I need to typically start them up at the same time. So in my root package.json, I have a dev script that does pnpm run -r. So this stands for recursive, and it essentially looks at all of our packages and submodules, and if they have a dev script, it runs them all. In this case, I'm also passing -- parallel because I want them all to run at the same time. Without that, it'll essentially wait for each one to finish before it calls the next. And then I'm also passing in aggregate output, so we see one single feed that has output from all of the tasks that are running. And so now if I run pnpm run dev from the root, it's going to find that task and then spin up my React Vite app and also spin up my Hono app. And so this is really great, and it works cross-platform. So as long as everyone on your team or everyone working within your monorepo is using pnpm, then they'll be able to run these tasks. On top of that, you can see I have all of my other tasks set up. And specifically, if you look at the build script, it does not run in parallel because there are various dependencies, right? And sometimes one package needs to be built before the other, and pnpm is able to figure that out based on dependencies. And so we don't run this in parallel so that our builds run in the correct order. But for test or linting, we can run those tasks across all of our projects all in one go. My next tip is to use Vite's proxy server if you have, for instance, a separate API and a separate front end. So now that I've spun up both of my apps, the API is running on port 8787 because it's using Wrangler, which is a Cloudflare tool. And then our front end is running on port 5173 because it's Vite. And so if we look in the browser, our API is here, and then our Vite app is here. Now, if I want these two apps to talk to each other, we could run into a CORS issue because our backend is on the origin localhost 8787, and our front end is on the origin localhost 5173. But whenever we deploy this application, it's all going to live on the same domain. So when you visit the index, the React and Vite app will load, but anything that is /API, the Hono app will respond. So check this out. If I attempt to create a new task here, which is going to hit the Hono API, we see the request go out, but you'll notice it's to 5173. So with this setting, our React app is just making requests against itself, essentially, but the Vite dev server will see that and then proxy those requests through to the Hono API. So inside of our Vite config, there's a section down here called server, and this is where you can specify your proxy settings. And my settings here say that if any request goes out to /API, that should be proxied to localhost 8787. So in the browser, we can see that request went to 5173/API/task. And so the Vite dev server saw that request and then in turn proxied it to 8787/API/tasks. Now, this is great because when I'm writing my React code to make these requests, I can just make fetch requests against /API. I don't have to specify the full URL because whenever I'm deployed, that's how it will behave. Anything that's /API will load the Hono app. Anything at the root loads the React app. And so this is definitely the way to set things up if your API and client are going to be hosted on the same server whenever you deploy. My next tip deals with deployment and how to deal with the client build of your React app, where to put it, and how to serve it up from your API. So whenever we deploy, we're going to build our React front end, and that's just going to get turned into static assets because it's just a Vite app. But we want those static assets to be built into the same folder that we're going to deploy our API from. So if we take a look back at our Vite settings, I actually have this build setting right here that says the outdir is in the API folder and then in the public folder. So go up a directory into the API package and then build it into public. So when I run a build, it's actually going to output those files here in this public folder. Now, as you can see from my editor, these are get ignored because I don't want to commit those built assets to my repo. But now that this public folder lives inside of here, I can configure my API to serve that public folder and all of the static assets inside of it. Now, this configuration is going to depend on where you're deploying to and what kind of app you're using. I'm specifically deploying this API to Cloudflare workers and then using their static assets feature. So in my Wrangler config, I have an assets setting that says the directory is public. And so essentially when I deploy this folder, everything in that public folder is going to be served up as a static asset. Now, the other piece of configuration you're going to need is for working with a single page application, right? Because our React app here is all static files. In this case, I'm using TanStack router, but you might be using React router. But essentially we have client-side routes. And if someone were to visit those routes directly, we want to make sure that the static assets are served up. So specifically for my Hono API, I have a middleware that looks at the incoming request. And if it does not begin with /API, then it serves it up from our static assets. But if it does begin with /API, then that means Hono needs to handle it. Now, this is specific to Cloudflare and static assets. If you're deploying with Hono and Node, they actually have a static asset middleware that you can just add directly. But for my specific type of deployment, this is the middleware that I need that basically says, if a request is not to /API, then we need to serve our root index.html, and then React will load and TanStack router will kick in and load the correct page. Now, like I said, this configuration is going to vary wildly depending on where you're deploying to and what you're using for your backend. But you essentially just want to search for the SPA rewrite configuration or SPA redirect settings, and whatever provider or whatever framework you're using will likely have some documentation on that. Now, my next tip is how we can share validators between both our backend API and our frontend, because we want to run validation before we put something into the database, but we also want to run validation on the front end before we send it to the backend. And in this case, I am using Drizzle for my database, but Drizzle provides the Drizzle Zod package. So I can take my database schema and then instantly get Zod validators that correspond to the different types of things we're going to do for this table, like selecting from the table or inserting into the table or updating rows in the table. So all of these validators are directly based on my table schema here. Now, you don't have to be using Drizzle for this to work. You could just define your Zod validators separately, but it is nice that Drizzle has this built in. And it allows us to change the schemas depending on what we're doing. Because for instance, whenever we're inserting into the database, there are certain fields that I don't necessarily want to include in the validation. Like because the ID is auto-generated and the dates are auto-generated, I don't want my schema to be validating for those. So we can use the built-in omit function from Zod to say that this schema will not allow those properties to be passed in. And then beyond that, we can add more validation. So in this case, I set a minimum length of 1 on the name column and a max length of 500. And depending on the type of database you're using, you could also add constraints on the columns themselves, but it's nice that you can further refine these schemas here. And say, for instance, you also had like URLs in your database, you can use all of the things built into Zod validators. So we could specifically validate this string as a URL or validate this string as an email. So this is great. And I can use these validators in both my API and in my client. So if we take a look at the API code, which does the inserting into the database, we can see when I define my routes, I pass in these validators. So So right here for our create method, you can see that the body is going to be validated using that insert task schema. And if we take a look at our front end code, specifically the form that allows us to create new tasks like this, you can see that it's using that exact same validator. Like we can go to definition, it's that exact same validator that's defined in our backend code there, but we can combine it with, in this case, with React hook form to use that exact same validator so it's validated on the client side before we send it to our backend. Now here specifically with Hono, they have this built-in RPC client where essentially you can take the type of your API and then use that type directly in the Hono client to get a fully typed client that knows about all of your endpoints. Now this works fine as is, but you could run into some performance issues inside of your editor because essentially every time you're using this variable here, the TypeScript language server has to infer and figure out all of the types of your Hono app. But if you take a look at their docs under known issues, they actually show you how you can essentially compile the types for the client ahead of time to get a much better editor experience. So here inside of the app, I have a packages directory, and then I have this API client, which has this specific code here. And whenever we run a TypeScript build, it's going to generate those types. And so that code lives inside of here, along with a few other types that I want to share. But my main tip for you is here in our package.json, I actually have a dev script which runs the TypeScript compiler in watch mode. And this means that the build process for this package is going to spin up at the same time as our Hono API and our React web app. And anytime there are changes inside of our Hono API, this build is going to automatically rerun, recreate our types here. And as you can see, all of the Hono endpoints are actually directly inside of this file. So whenever our client-side code is attempting to call any of these typed endpoints, the TypeScript server doesn't have to figure that stuff out dynamically. It's just using this statically built file that instantly gets updated anytime there are changes in our backend. Now, because this package is dependent on the API, there are a lot of types and things that the API does that we would potentially need dependencies for as well inside of this subpackage. But this package is being used inside of our React app, and I don't want it to be dependent on all of those other like backend specific things. So if you take a look at our API and look at its package.json, you can see that I have specific exports here. And so any package that's dependent on the API only gets access to these two things. You can either get access to the routes, which is where we get that Hono app type from, or the schema, which is where we get access to our Zod validators. But that means we're not exposing all of the code from the API to the client. We're only exposing these specific pieces. And this allows us to be much more careful to not import like server specific packages or import environment variables or different things like that. Essentially, when we're working in these files, we know that they're going to be accessed in both the client and the server. And specifically, if you're working with Hono, you can see how I set this up here. I actually have a separate file here in my routes folder that exports a Hono router that only has specifically the endpoints that I care about on it. So this doesn't have all the extra middlewares and everything else that are specific to the backend. It just has the endpoints that the front end needs to be able to call. So the sole purpose of this file is to export that router, and then that router type is actually what is used inside of our Hono client here. But I have this reusable register routes function where I can pass just like a base Hono app to it, but I can also pass my full Hono app, which has all of the middlewares and everything else that it needs. So all of our routes are registered in this one spot, which means I can use them for the types, but then I can also use them for the actual Hono app. Now, this is a little bit more work, but I have found it's the best way to make sure that our API client here only has the dependencies that it needs and doesn't need all the extra stuff that the backend needs as well. Now, when using pnpm workspaces, it's up to you how you set up all of the various workspaces. And for the app that I showed you today, I set all of that up manually, right? I set up the eslint sharing and the tsconfig sharing manually and everything else. There are other tools out there you can use in conjunction with pnpm workspaces to get more things kind of built in and generated for you. So NX is one of those. I've used this for a few different projects, and they actually have a CLI tool with a bunch of different generators built in. And they set things up in a way where your TS configs and your eslint configs can be shared automatically. And like I said, they have generators of all types. There's also Turbo Repo, which I haven't used myself, but it has similar tooling. And then there's also Lerna, which I do have experience with it. I used it a long time ago before some of these other tools existed. And now Lerna is actually maintained by the same people that maintain NX, but it has some features of its own as well. So it's definitely worth checking out. Now I want to walk you through some alternatives to monorepos. As we talked about before, monorepos aren't a silver bullet. They're not going to solve all of your problems. And sometimes you can run into configuration issues, slow builds, potentially privacy issues if multiple people have access to that repo. So let's go over a few alternatives. And the first is Git submodules. Git submodules allows you to have multiple separate Git repos that are all referenced within the same Git repo. So they all still exist as separate Git repos, but there's a Git submodule command you can run that actually pulls in that remote code. And so this is fine. I think one of the main issues you might run into with Git submodules is if you need to reference other files via relative paths. Because like in the example I showed of configuration sharing, we're essentially just importing files from parent directory. So you might run into some issues there where those Git repos won't really ever work unless they're cloned inside of the parent repo that has them as submodules, but it is an option. Another option is to publish private modules, and there's a lot of different ways to go about that. So essentially, instead of having everything in the same repo, you could have them in separate repos, do exactly what you're doing now. But then if you want to share code, you publish them to some registry and then install them as dependencies in the various projects that need to share those dependencies. And so npm actually has a paid tier where you can publish private packages, and essentially only the team members that you allow can install those packages. So that's one way. Essentially, you use npm to publish. It's not public. Only the people you allow will be able to install it. But from there, you can install those dependencies across your various repos. Now, a free self-hosted solution to private packages is Verdaccio. So you can install this on a server and then point all of your npm installs to this server, and you can also publish packages there. And what's nice about Verdaccio is it actually serves as a proxy. So if you try to install something from Verdaccio, but it actually lives on npm, Verdaccio will cache and proxy that install to pull it in from npm. But you can publish modules here. And for instance, if you had this only existing on an intranet, not exposed to the outside world, only computers on your network would be able to install packages that were published there. There are also some paid hosted options. So you can also take a look at GitHub packages. They will essentially allow you to publish private packages inside of private repos. And so you can publish them there and then reference them from other projects. That's one solution. And then there are some more enterprise hosted solutions. So one that I've used when I was consulting before is this thing called JFrog Artifactory. This is not an ad for them. Check them out. See if this is something you would actually want to use because it is a paid product. But essentially, it lives on your intranet and it hosts all your packages, but it can also host Docker containers and other things like that. And then there's also AWS Code Artifact. So if you're already in the AWS ecosystem, you can spin this up and publish your private packages there. There are likely other solutions as well. If you know, let us know down in the comments. But like I said, monorepos aren't always the solution you want to reach for. So if they're not, there are other ways of sharing code, and here are just a few options. That's it for this video. If you have any comments, questions, concerns, let me know. All of the code that I showed you today is going to be linked in the description, so you can go check it out, poke around, steal some of the stuff, and add it into your own monorepos. YouTube thinks you're going to like this video, so check it out, and subscribe if you haven't yet. All right, I'll see you in the next one.